welcome to Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada, doing all sorts of stuff. It's a little hot out. Stay cool, stay hydrated, and I'll keep working on Tronics. So let's show what I'm working on. I have a couple like designs that I'm kind of, fixing, repairing, whatever, getting back to, and then a couple new designs as well. So let's go to the overhead. So the first thing is I am slowly getting through testing everything for the ESP32-C6 Feather. I like to use a Featherwing TFT to test because it uses I2C for the touchscreen and SPI for the display, and it's like, fairly high speed. So of course I reset this. Hold on. Okay, there you go. So this is a simple touch interface demo. Just verifies that like everything's working fine. All is good. Analog pins are working. I2C is working. SPI is working. I still do low power tests, and then like I've been kind of like delaying sending this board out, but I feel like I'm really close to wrapping it up. Hopefully, we'll order PCBs in the next week or so. In the meantime, one design that I did really fast goes like a speed round because I just designed it, ordered prototyped PCBs, and then they came great, and I'm already designing the tester within like a week. Is the Adalogger Feather RP2040. I was reordering some Feather M0 Adalogger PCBs, and I realized like, oh wow, I don't have a version with the RP2040. It's our standard Bones board with STEM QT and everything, and then SD card slot that you can has card detected everything. So I spent this morning a little bit of time this morning, so I designed the tester for it. So it's nice and fast. You just plug this in and it programs the chip over USB. I always forget this is a micro USB. Hold on, let me grab my micro USB. Plug it in. It loads the UF2 on. It does a test, and when it passes, it says passed. It's pretty fast, like 8 seconds to program and test. And then the default demo is a NeoPixel swirl, and then it just prints out the contents of the SD when you insert it, and then when you remove it, it says removed. So like I said, this was pretty fast. I mean, one of the nice things about having sort of a standardized test system where I have the brains boards, and we like get like 50 of these at a time, and then just like the device under test board, and this is actually the same as the DVI. Because I was like, oh, it says the same pin usage, so I just reused the DVI test board. I was absolutely able to get this up and running within 2 hours. So anything that saves me time, lets me get designs out the door faster. So that's that. Let me see. Sorry, what else was there? Oh, I'm also slowly getting back to some floppy hacking. So one of the things issue I had was I had some floppy drives I bought, and some of them didn't have an index pulse. And apparently it's actually not required by a lot of motherboards. They don't need an index. They just look for data being received, and then they don't, the index pulse, to be honest, isn't really required, which is why the Apple II doesn't need it. You need it if you're like cloning some copy protected floppies, but it's actually, the index pulse is not actually needed. But I still wanted to be able to tell like when floppy drives I had good or bad index pulses. So you just put a floppy drive in there, and then when you press reset, it will test, and then it actually does a sector check for the first track. So 2 sides, first track. It just checks all let's see, I think there's like 18, I don't remember, it was like 36 sectors per track, and there's 2 sides, there's 18, and maybe I'm doing 2 track, I don't remember. Yeah, because I'm doing track 0, track 1. So 18 sectors per track, 2 sides, 72 sectors total. And it verifies that they all have the right MFM data. So if it's a fat formatted floppy, it'll it'll even if there's no data on those tracks, it'll at least come up as an empty format. So it'll be like properly formatted sector, so you know that the disk is reading correctly. So this one is good, but I have another one that doesn't have an index pulse, and so I'll grab it real fast, maybe. Reach it. So this drive, like I said, it it works, but it doesn't have. Sorry, doesn't have an index pulse. You can even see I wrote on it like no index. You plug it in, power it, and this time when I run it, it says no index pulse pound. Test fail. So yeah, this way I can quickly test these drives instead of just being like, why isn't it working? And then like poking around with my oscilloscope to see like why is, probing around trying to figure out why it's not working. There's no index pulse. Like I said, it's not necessary, but I think I wanted to stock floppy drives. So I got a couple, like, refurbished ones. Like I said, I prefer to sell ones with an index pulse. Okay, and then I did a bunch of quick designs. So let's go, I'll just show how am I doing on time?
Just 7-minute mark.
Okay, I have time. Okay, let me show, yeah, let's go to the computer and I'll show off. I did a couple designs. So one I did, remember I did the IRDA board last week because I think I was researching IRDA chips. So this is the TFBS 4711, and then this is that MCP2212 transceiver encoder codec thing. So this PCB is done. And then I was like, oh, I should make one that's just like generic for receiving and transmitting like IR 38 kilohertz data. So I just like merged my infrared transmitter and infrared receiver. So this is the receiver. These are two IR LEDs, high power, one's right angle, one's vertical, horizontal. Driver FET, a receiver, so you can have both. And then I just kind of reused a JST-PH connector because I didn't want to have two cables and like, I don't know, I figure it's Grove-like. So there's one pin for IR out, one for IR in, and then two little LEDs to let you know data is being received or transmitted. So I did that design. What else did I do? I did the transceiver. Oh, I did another HUSB. So I really like our HUSB breakout. It's a dummy board for USB Type C power delivery. But I wanted one that was like no soldering required, like you just plug and go. And so I made a slightly different version. Oops, maybe you can also turn. Always so confusing. T-document. So this version, it still has the it's almost the same HUSB, but this time instead of having solder jumpers, I put a little one of those like dip switches. Remember, like I was talking a few weeks ago about half pitch dip switch. Well, I could actually fit a full 6 dip switch in here, and so you can just like flick whichever switch you want to have it be whatever voltage you want, and then these are the resistors to set it. Semi-QT connector if you do want to have solderless and more advanced control. USB Type-C, of course, and then terminal block on the output with a power good LED. So it'll be like fully assembled, ready to go. So for advanced usage, folks who want to who don't want to like, it'll be more expensive because the dip switch is expensive and soldering the terminal block is also expensive. But for a couple bucks more, it's like it's ready to go, and you can basically make a dummy block very easily. That's easily reconfigurable. So I did that, and then we were chatting with Anne about some retro stuff, and I realized we don't have an RS-232 breakout board for level shifting RS-232. So I have to remember, where did I put it? I think I put it under level shifters. Yeah. So I designed two RS-232 boards. One using, this is the Max 3232, and you have two sides. It's actually rotated. So you have the high voltage side here. And you get two receiver transmitter pairs. So it's like RXTX, CTS, RTS, or DTR, whatever. And then this is the low voltage input. And then there's a bunch of capacitors for the boosting. And then I also designed one for a full breakout to do all 9 pins of a DE9. And this one is using, so you can see there's like all these pins, and there's DCD and DTR and DSR and, you know, CTS and ring and invalid and off. This is using the Max 3243, which has a full 5-3 transceiver pair set. All right, so that's, I think I got to everything, right? How much should I be? Okay, great. Let's go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada helps you. Yes, you find the things on digikey.com. Ladyada, what are you looking for this week?
Okay, so this week I've been looking to experiment with a little bit RS-232. Just go to the computer and chat about it. So RS-232 is like, before our USB, we had these computer ports. They were either 25 pin or 9 pin connectors on the back, and you would use them to connect mice or even printers or accessories or your Palm Pilot 5. If you wanted to like sync data between your computer and your Palm Pilot. These were slower than USB, and you know, only sent data in raw 8-bit packets, or even 7-bit, or modems also use them historically. Don't really appear on computers anymore, except sometimes, you know, you actually still can get computers that have serial ports, because there's actually still some old equipment. I've definitely seen like barcode scanners and scales and like lab equipment stuff that still has RS-232. Like I said, it's definitely older, but it's, you know, it was on every computer. One of the first microcontroller boards I designed, you know, again, before USB wasn't on computers yet. To program the bootloader on the ATtiny 2313, you would use a serial port. So the serial port and a serial converter, because RS-232 voltages they weren't 0 to 3 volts. It was -10 to +10. Although it actually was, the hysteresis was a little bit flexible. It didn't have to be ±10, which, like I realized later, as long as it was like ±3, but it definitely, or like 5. It definitely had to be like ±5, and like ground was like the crossing point. So it definitely had to go above and below. So to do that, you needed a chip. And so in my case, you know, the one that we all used was the Max 232 Classic dip chip. You needed 4 capacitors because you needed whatever the input power supply. So here there's actually a 9 to 5 volt power supply. You need a capacitor on the input, 5 volts, and then you need another capacitor to double the voltage, because you would use it as a charge pump. You would like flip the voltage back and forth to double it. So that would get you from 5 to 10 volts, and then you would have a inverter. So then you would have something that would take the 10 volts and convert it to -10 volts. And that's another capacitor. And then I think the third one is, I don't remember, some, you know, maybe the regulator for the chip itself. Yeah, and I wrote a little Java applet. This was very 90s. Anyways, so thankfully these days we have chips like the RP2040 that have built-in USB bootloaders. It's like a magical time, believe me. But there's still a lot of times where you're dealing with retro technology. Like I said, there's still plenty of industrial equipment that uses RS-232. I still see it, and you can still buy computers that have hardware COM ports. Absolutely, for sure. So let's go to DigiKey and let's look at the Max 232. So this is an older chip. But let's say we wanted to buy it, you know, nowadays. Can you still buy it? Heck yeah. Still stock the DigiKey, even in DIP format. So this is a transceiver with it's full duplex, which means it has RX and TX 2, which means 2 transmit, 2 receive. I think if I remember correctly, I think on the AtMax and definitely on chips like the original Arduino, which also had serial, they use the DTR pin to do an auto reset. That's kind of the magic, right? You would when you wanted to upload, you'd connect the serial port. When you opened it, the DTR pin would toggle because it's the like pin that indicates, hey, the serial port's open. And that would just immediately reset it, and then the bootloader would run for 3 seconds, and then you'd upload. So I believe the AtMax, I think I did the same thing. I think it was pre-Arduino. Arduino didn't exist at the time, although it's been a while. So RS-232 transceiver, but the one thing that's a little annoying about this is one, it was limited. 100, it could do 115 kilobit per second. That's why it's data rated for 120, because it's like a little bit over 115. But there's times when you want to maybe communicate at 250. That's not unusual. So we'll get one that can do 230, 250. Second, this one has a voltage supply of 5 volts, because at the time, people didn't really use, well, there were 3-volt microcontrollers, but like a lot of people still ran them at 5. So this chip was at 5, but let's look for something that's surface mount, not through a hole, can run at 3 volts as well as 5 volts, and maybe can go a little bit faster than 120. So to save us a little time, let's just click on some of these to get us, kind of fast track us to the search we want, because we definitely want transceivers that do RS-232. The hysteresis I don't really care, and the data rate will set, and then the package in the case we'll do later. Okay, so we're here, and already we've kind of like fast traveled. So let's look for surface mount, because like I said, it's gonna be pick and placed. Number of drivers and transceivers. So again, a really common one is 2, because you get like the DTR pin or CTS, RTS, so it's flow control plus RxTX. And then let's look at the voltage supply. So this one looks like it'll cover, I want to make sure it covers 3 volts and 5 volts. So I'm just going to like pick through, and I'm control clicking. Going to skip this because it's not 5, grab these, and then these are all higher than 5. So let's select these. Like I said, I want the higher data rate. So we'll skip the 120 kilobits. And let's only look for ones that are in stock. And can skip the marketplace ones too. Okay, so let's see what we got. So not too surprising, there's the Max 232. So what did they come out with? The Max 3 232, which is 3-volt compatible. So that's actually, I think, what I used on this design, which is, a tiny, cute, the 3232. Starts with Max, because originally it was made by Maxim, now Analog Devices, but to be honest, it's a Jelly Bean part. You'll find many 3232, so TI has the TRS 3232. There's the TI Max 3232, and then Max Linear makes the SP, whatever. There's tons. All are good. They're all going to be equivalent. You still need those capacitors. There was actually a version of the Max 232, I think it was the Max 233, that had the capacitors built in. But it was like very expensive. It was very cool though, because it was like the capacitors were in the package soldered in. So it saved you a lot of board space. But like I said, it was significantly more expensive. It was like $2 or $3 compared to the 40 cents you see here. Okay, so the only thing is, for my bigger version, like if you're connecting to equipment, you may need to have the ring indicator, you might need to have RTS, CTS, DSR, DTR for data ready, and also I actually rather like the invalid and off pins. So these are pins that let you know when something's plugged in on the other side. So it's kind of like a link connection indicator. So it is kind of nice that these are little extras that they added to chips later. The 232 and 323 do not have those extras. Okay, so let's get rid of the numbers and receivers and drivers. So if you do want to have like the full all DE9, so the DE9 has 9 pins. So the 9 and DE9. But one pin is ground. Oh, and there's also the earth and ground. So you actually have 8 pins, and then 5 of them are transmitters and 3 of them are receivers. So it's not like 4-4. It's actually 3-5. I'm going to grab both the 5-3 and 3-5 because, of course, you can have them go either way. I think it's just a typo. And I still have the high data rate, and we'll still get the voltages available. So also a lot of options here. Yeah, I don't see anything else to filter. I mean, you can do some operating temperature stuff. The Max 3243, so you can see they're all kind of have the 2s and the 3s in there. This one looks really popular. There's quite a few of them. 238. Let's start by price. So, you know, it's interesting. For not much more than the 2-pin version, you can actually get a the 2-2 transceiver. You can get a full 3-5 transceiver in TSSOP with, you know, wide operating temperature range. Oops. So it's weird. Oh no. I didn't think to click on the data sheet. Let's just Google for it and see if we can get. There you go. Okay. Love this rendering. Old style, but yeah, this has the extra pins online, which is same as like it'll let you know when the other side is connected. Shutdown, which lets you shut down the chip for low power usage, or if you just want to high Z all the pins. And like I said, you just need a couple capacitors, can run it from 3 to 5 volts. 4 caps to generate the positive and negative voltages, and you're good to go. This is, you know, 5 inputs, 3 outputs. Yeah, 5 RS-232 inputs, 3 outputs, and then the 4 capacitors. And then, you know, the optional shutdown online and status. There's also this R2 out, which is interesting. So it's a before the shutdown capability, you can always monitor the ring input, which will let you know, even if it's shut down, if something is ringing you, so you can like wake up the modem, or wake up your computer when the modem rings. I know it's like it's all very, it's like it's funny to look at USB serial converters and be like, wow, the DCD pin is still there, even though like it's not. It's a weird thing to have a USB device do. Anyways, this is in stock under $1, and you get all your transceivers. So, you know, basically this is the chip I'm using here. They're all the same pinout. So, you know, anything with the 3243 SP TRS Max, you're good to go. And like this, no matter how many connections you need for your RS-232 device, this will get you going with 3 or 5 volt logic compatibility. So this is my pick. It's a great search.
And that's the great search.
Where in the world is that part I need? The great search with DigiKey.
All right, thanks for joining us, everybody. Shows throughout the week and more. Pick up something from Adafruit.com. Keep us going. Thanks so much.
Thanks, everybody.